Lay a calcite crystal on a printed page and the letters double. Not blurred, doubled. Two clean copies, because one ray went in and two rays came out, the ordinary and the extraordinary, crossing the same transparent block at two different speeds. The crystal does not carry one light cone, it carries two. Now take the crystal away and heat the air above a road until it shimmers. One ray this time, but bent, because the speed of light varies from place to place and the ray curves toward the slower region. Birefringence and the mirage. Two things you can watch on any summer afternoon. The case in this chapter is that both of them happen in the vacuum itself. The crystal is the chakra lattice, and what we call the geometry of spacetime is what its varying stiffness looks like from the inside. So here is the question to crack. Has the substrate built a real spacetime, or a very good optical illusion of one? One thing before we begin. Advaita Chakra Theory is a speculative, exploratory framework, not established, peer-reviewed physics. Much of what follows is honest conjecture that still needs validation. Watch it in that spirit as ideas to test, argue with, and refute. Start from what Part 1 already handed us. Expand the substrate Hamiltonian to quadratic order about the locked ground state, read off the Goldstone branch, and the soft mode disperses linearly omega equals C effective times the magnitude of K. And the speed is fixed by two things only, stiffness and inertia. C effective squared equals A0 squared times J over I. That is derived, and it is the spine of the whole book. But notice the hidden assumption. That formula is a single number because it presumes the couplings are the same everywhere on the lattice. So relax it. Let the stiffness carry a slow spatial profile because the condensate amplitude, or the local density, or an external strain varies from region to region. Now C effective is a function of position, the square root of a naught squared times J of X over I. One cone becomes a field of cones, each one slightly wider or narrower than its neighbor. Nothing has been added. We only stopped pretending the lattice was uniform. Here is where the geometry appears, and I want to be precise about how, because this is the load-bearing move of the chapter. In the slowly varying regime, the iconal limit, where the profile changes little over one wavelength, the soft field obeys 1 over C effective squared of X times the second time derivative minus the Laplacian equals 0. Now compare that, term for term, with the massless Klein-Gordon equation on a curved background. The comparison is not loose. There is exactly one metric whose coefficients reproduce those two terms, G equals the diagonal of -1 and 1 over C effective squared 3 times over. The line element is minus dt squared plus 1 over C effective squared of X times dx squared. Nobody put a geometry into the Hamiltonian. The Hamiltonian knows inertia, stiffness, and locking, and nothing else. The metric was read off the coefficients of the substrate's own equation of motion. And the honest tag on this box is standard, not derived. This is Gordon, Unruh, and Visor's analog metric, the same algebra, relabeled. What ACT contributes is not the equation. It is the claim that the medium is not a fluid inside spacetime, but the substrate of it. The word optical here is exact, not decorative. Define a refractive index the ordinary way, n of x equals C0 divided by C effective of x. Where the lattice is soft, the light is slow, and the index is high. Fermat's principle says a ray extremizes the integral of n along its path, and that condition is identically the null geodesic condition of the metric we just read off. So the substrate is a piece of graded index glass whose index is set by the local stiffness. The mirage over the hot road and the lensing of an emergent spacetime are not analogous calculations. They are the same calculation. One consequence is worth stating carefully because an earlier draft in this corpus got its sign wrong, and it had to be corrected. Rays bend toward lower C effective, toward the soft region, toward the high index, toward the slow side, like light bending into the warm layer of air, and like a gravitational lens. Both the symbolic Levi-Civita computation and the numerical ray trace agree, and the sign was fixed before any curvature formula was trusted. Now the birefringence, which is where the chapter earns its title. That first cone used one null vector, the Goldstone. But a composite site carries C channels, so the dynamical matrix has C branches. One is the exact gapless Goldstone, the other C-1 are gapped. And each branch has its own cone speed. The correct expression is not the naive eigenvalue of I inverse J. It is the stiffness expectation value taken in the mass eigenbuses C effective squared for branch alpha equals V alpha transpose times A0 squared J times V alpha divided by V alpha transpose times I times V alpha. That is derived. Read what it says. When the channel stiffnesses are unequal, the branch speeds are unequal, and the vacuum carries several distinct light cones at once. That is birefringence in the strict crystal optics sense, different modes, different speeds, one medium. Calcite, but between internal channels instead of crystal axes. And I will flag now what chapter 6 will make sharp. The naive eigenvalue reading is not merely inelegant, it is wrong by as much as 30%, which forces an uncomfortable question. Our universe appears to have exactly one light cone. Photons, matter waves, everything share one speed to spectacular precision. When does the substrate give that? The proposition is short. The several cones collapse to a single universal cone if and only if the stiffness matrix is proportional to the identity in the math indices. A0 squared J equals C effective squared times I. If they are proportional, every quadratic form returns the same number, whatever the eigenvector. If every cone agrees across a complete eigenbasis, the two matrices must be proportional, necessary and sufficient. Now the honest part. The substrate Hamiltonian permits arbitrary channel stiffnesses. Equality is a condition imposed on the couplings, not a consequence of them. So in this theory, Lorentz invariance is a selection, not a derivation, tagged asserted, and it stays asserted until somebody finds a symmetry of the composite site that forces it. Meanwhile, the residual splitting is a real, falsifiable signature, gamma-ray burst, and blazar polarization over gigaparsec baselines already bound any cone splitting below 1 part in 10 to the 15. And now the defect in the birth certificate. Look again at the metric, the lapse is constant. Γⁱ equals -1 everywhere, whatever the stiffness does. A metric like that is called ultrastatic, and for it two things vanish identically, the Christoffel symbol gamma I00, and the time-Ricci component R00, both derived, both provable in a line. The consequences are brutal and precise. Gamma I00 equals 0 means a body at rest is not accelerated, no Newtonian force. R00 equals 0 means, through the Newtonian limit, that there is no gravitational potential at all. Take the worked example, a Gaussian stiffness well 1 part in 1,000 deep. Array at impact parameter equal to sigma deflects by about 1.5 milliradians, real lensing, bending into the soft region. But a clock carried through that well ticks at exactly the coordinate rate. No Shapiro delay, no redshift. In general relativity, that deflection will come with a definite correlated time delay. Here the bending stands alone. The substrate hands us light and geometry for free. It does not hand us gravity. This metric is a lens, not a star. The verdict in ledger form. The optical metric is real and it is exact, but its tag is standard. The algebra is analog gravities, relabeled, and what ACT adds is ontology, not equations. The per-channel cone speeds are derived, honestly, from the multi-channel dynamical matrix. Single-cone Lorentz invariance is asserted, a tuning of the couplings that no substrate mechanism yet forces. And the ultrastatic identity, R00 equals 0, is derived, which is precisely why this geometry cannot pull. Nothing new was added to get a spacetime. That is the triumph. That the spacetime is forceless is the bill, and it comes due in chapter 7. Notice what was not claimed here: no gravity, no derivation of Lorentz invariance, no new number that experiment has not already measured. What we have is a lattice that manufactured a Lorentzian geometry out of nothing but stiffness and inertia. Next time we stop describing that geometry and start measuring it, the exact scalar curvature in closed form, and the 30% correction that kills the naive cone speed. Chapter 6 Curvature, exactly. A word of acknowledgement. This work was inspired in part by the non-dual teachings of Sri Narayana Guru, that the creator, the creation, and the substance of creation are fundamentally one. Symbols from the Hindu tradition, the Sudarshan chakra and the Shivalinga, suggested the analogies behind the chakra model. They are acknowledged as philosophical and symbolic inspiration. The physics stands on its own. Thank you for watching. If this made you think, the book and the next chapter are linked below. Until then, one substance and how far it reaches.